Hello, welcome to this massive open online course on probability and random variables for wireless communications. Alright. So, let us start our discussion with the concept of an experiment, right. So, when we perform an experiment, so we frequently perform experiments and those experiments result in those experiments lead to outcomes. So, these experiments lead to outcomes and these outcomes are random in nature. These outcomes are random if they cannot be exactly predicted. These outcomes are random. So, the outcomes of these experiments, we say they are random if they cannot be exactly predicted. For instance, let us take a simple example. For example, let us take, since this course is about probability for communication systems or wireless communication systems, let us take a source, an information source. In communication, we talk about information sources, and let us say it is generating information symbols 0, 1, zeros and ones, for instance 0, 1, 0, 0, and this is the sequence of information symbols. Now, for this information source, right, at any instant we do not know exactly what is the next information symbol. It can either be 0 or it can be 1. Right. So, the next information symbol, there is uncertainty about the successive information symbol, there is uncertainty about the next information symbol. So, these information symbols, these are random in nature. We say the information symbols are being generated randomly. So, there is uncertainty about the next information symbol. Hence, these information symbols are random. We say these information symbols are random, or they are being generated randomly. That is a qualitative description of randomness. We say that the information symbols are being generated randomly because there is uncertainty regarding the next information symbol that is generated by the source. So, let us now develop a framework to formally characterize probability and randomness. Alright. So, let us start building a framework. The first thing we would like to define is what is known as the sample space. Now, the sample space is simply put, this is the set of all possible the set of all possible outcomes of the experiment, this is known as the sample space. The sample space is the set of all the possible outcomes of the experiment. For instance, let us again take a pertinent example from communication, example from the context of communication for sample space. Let us take a look at an example, and in this example we are going to look at a digital modulation format. A digital modulation format. More specifically, we are going to consider what is known as Emery PAM or Emery pulse amplitude modulation. So, I would like to look to illustrate this concept of sample space. Let us look at this digital modulation constellation, which I am terming, which is an Emery PAM. Some of you are already familiar with digital communication, must know this. This is Emery PAM or Emery pulse amplitude modulation, where you choose from one of several amplitude levels to convey information. For instance, let us choose m is equal to 4, implies basically that there are 4 symbols. These symbols are equally spaced on a line. So, I have minus a minus 3, let us call this alpha, minus 3 alpha, minus alpha, alpha, comma 3 alpha. These are the 4 symbols, right. So, I have 4 symbols minus 3 alpha, minus alpha, alpha and 3 alpha spaced at intervals of 2 alpha. This is pulse amplitude modulation, that is choosing from one of 4 possible amplitude levels to convey information, and these are chosen randomly, that is the next, there is uncertainty about the next amplitude level. So, the sample space clearly for this example, my sample space here is equal to, basically the sample space is nothing but the set of amplitude levels minus 3 alpha, alpha, minus 3 alpha, minus alpha, alpha, comma 3 alpha. So, for this Emery PAM where m is equal to 4. So, m is equal to 4, I am considering an Emery PAM example, and my sample space for this, the sample space for this is given as minus 3 alpha, minus alpha, alpha, comma 3 alpha, and each of these elements of this sample space is known as a sample point. So, these are known as the sample points. Okay. So, I have a sample space which consists of all the possible outcomes of the experiment about which there is uncertainty, hence these outcomes are random, and each of these possible outcomes, each of the single possible, so this each of the single possible outcomes, these are known as sample points, correct. Okay. Now, also let us define what is known as an event A in this. Let us define an event, the notion of an event, which is the other important thing. An event is any subset, an event is any any subset of S, all right. For example, consider A, the set A is equal to minus 3 alpha, comma alpha. Clearly A is, we can observe that A is a subset of F. So, A consists of, the set A consists of the symbols minus 3 alpha, comma alpha, correct. So, A is clearly a subset of S, therefore, A is an event, A is a random event of this experiment. So, A is an event. So, this A, this is an event, and also from elementary set theory you must be familiar with the definition of from the definition of a subset. Subset A is a subset of S, implies every element of A also belongs to S, correct. So, A is a subset of S implies that every element of A is also present in S such as set A which consists of, which is a subset of the sample space S. Therefore, it consists some sample points in S that is known as an event, Also further, from elementary set theory, you should be familiar with the concept of a complement of a set or the complement of an event. Now, let us consider, to illustrate it pictorially, if this is my sample space S, if this is my event A, all the events, all the sample points that are in S, but not in A, for instance, this shaded region over here, that represents the complement. So, A complement, so from elementary set theory, A complement, we have A complement equals complement sample points in S, but not in A. A complement equals the complement of A implies the sample points implies A complement equals sample points in S but not in A. So, A complement is the set of sample points which are in S, but which are in the sample space S, but not in A. For instance, let us go back to our example. I have S is equal to minus 3 alpha, minus alpha, alpha, comma 3 alpha. I have my set A, which we have defined as minus 3 alpha, comma alpha. Therefore, A complement is the set of elements that are in S but not in A. So, A complement equals minus alpha. You can see that the elements, the sample points in S but not in A are minus alpha, comma 3 alpha. Therefore, A complement is minus alpha, comma 3 alpha, which is denoted by a bar over the set A. Okay. Now, similarly, let us come to the next aspect, again from elementary set theory. This is also something that you should be familiar with. A union B equals sample points, that is the union of two sets, A union of two events A and B, which is denoted by A union. So, this is the symbol for union, equals sample points which are either in A or in B, and A intersection B equals sample points in both A and B. So, we have two operations, A union B and A intersection B of two events A comma B. It is very simple, and from elementary set, these are similar to elementary set theory. A union B is the set of all sample points which are either in A or in B, and the event A intersection B is the set of sample points which are both in A and B. Again, let us go back, let us take a simple example. We have our example in which A equals minus 3 alpha, comma alpha. Let us say B equals the event B equals minus alpha, comma alpha. Then A union B equals elements which are in either A or B, that is minus 3 alpha, comma minus alpha, comma alpha, and A intersection B equals event sample points that are both in A and B, that is equal to alpha, right. So, we have defined the union of two events and the intersection of two events. And let us also define now a special event that is also known as the null event phi equals the null event, also denoted by the empty set, that this is the null event, that is it contains no sample points, does not contain any, this does not contain any sample points. Further, we can say two events are mutually exclusive if A intersection B is the null event. So, two events A comma B are mutually exclusive if A intersection B equals phi, the empty set, that is to say they have no common, A comma B have no common sample points, That is, we can say that two sets, that is two events A and B are mutually exclusive if A intersection B is the null event, that is A and B have no common sample points. For example, again let us take a simple example from our MPSK. If A contains the symbols -3 alpha comma alpha, B contains the symbol minus alpha, then you can clearly see that is we have A intersection B is equal to phi, and this phi is the empty set, and we say that A and B, we say that these events A and B are mutually A comma B are mutually exclusive. Further, it is easy to see some properties which can be easily clarified with a diagram. Let us see some properties which can be clarified with a diagram, a picture representation. Let us say this is my sample space S. We can clearly see that S complement is equal to empty set, that is the complement of the sample space, that is complement, remember the complement of an event is all the sample points that are not there in the event, but are there in the sample space. Naturally, if you look at the sample space, the complement of the sample space, that is all the events which are not in the sample space, which is the empty set phi. And similarly, phi complement, if you look at the complement of phi complement is S, because we are looking at phi complement is the complement of the empty set. All the sample points not in the empty set does not contain any sample point, therefore the complement of the empty set is basically all the sample points in the sample space, which is the sample space itself. Complement of empty set is complement of all, which is basically all elements not, or all sample points, not elements, all sample points not in phi. So, phi complement is equal to S. Further, if I have any set A in this, and this is of course A complement, this is of course A complement, then I have A union A complement. Look at this, if I have A union A complement, you can see A complement contains all the elements in S that are not in A, therefore, naturally A union A complement is the sample space S. Further, A complement intersection A and A complement do not have any elements in common, therefore, A intersection A complement is the empty set phi, correct. A union A complement is equal to the sample space S. At the same time, A intersection A complement, that is basically if you look at the intersection of A and A complement, that is the empty set phi, because A and A complement do not have any sample points in common. Further, the last property which is also obvious, that is if I take the complement of A complement, that is if I look at this picture, all the elements that are not there in A complement but are there in the sample space is A itself. So, A complement complement. So, this is all elements not in A complement but in S, and that is A itself. So, A complement is. So, we have some key properties, that is the complement of the sample space is the empty space, empty set, the complement of the empty set is the sample space, A union A complement is the sample space, A intersection A complement is the empty set. This is also known as the null event, the empty set in the context of an experiment and outcomes, this is also known as the null event. So, A intersection A complement is the null event, A complement, the complement of A, the complement event of the complement event of A is A. These are some properties which are which I will not go into the details of, and which are fairly obvious from both from elementary set theory and also from the simple diagrammatic representation that is given here. So, we will end this basic module here about experiment, outcomes, events which are basically subset of the sample space, and the various operations on events, that is the union, the intersection, the complement, and some properties of these events. So, we will end this module here. Thank you very much.